Okay, hi everybody, and welcome to our session today. Welcome especially to any students who are listening and interested in some of the science careers or STEM careers we're going to hear about today. Some of you will already be using the Science Mastery curriculum, and this is a collaboration between Science Mastery and Founders for Schools. And we're really interested in sharing with you the details of some of the really wonderful and interesting careers that the people you'll be hearing about today are doing every day. So before we hear a more detailed presentation about each of the careers today, I'm just going to quickly go around the group of speakers and ask them to share their name and their role for us, and then we'll hear from each of them in a little bit more detail. So first of all, to Marta.
Hi everyone, and thank you so much, ladies, for having me today. So I'm a senior client liaison ex-trader at one of the brokers in the London Metal Exchange. And hopefully I'll be speaking to you because sustainability, footprint recycling, those are the hottest topics. And when hopefully I'm not going to bore you because it's one of those topics that one can talk for months rather than a few minutes. But it's something that affects every single thing that you've got in your own household, so which you may not realize.
Amazing, thanks, Marta. And next we have Sarah. Sarah.
Sarah, it's fine. Hello, I'm Sarah. I work in London in the energy industry. I work in the renewable energies and batteries field, focusing battery storage. And I'm going to explain you a little bit more on how important are the batteries in the electric system now, and how can you develop a project and connect them to the network.
Fantastic, thanks, Sarah. Then we have Yvonne.
Hello. So I also work in batteries, but in more specifically scientific field. So I am a PhD researcher at the University of Oxford, looking into next generation batteries.
Amazing, thanks, Yvonne. And then we have Laura.
Hi, I'm Laura. I'm a health, safety and environmental advisor. So I work for Hitachi Energy. So we're an energy company that helps connect everything up and make sure it's all connected to the grid. So power comes to your home.
Amazing. So you can hear that all of the careers you're going to hear about today have to do with STEM or science saving the planet in different ways. As we go through the session, please feel free, teachers or students, to pop questions in the chat. And after each of the presentations, we'll go back and look at those questions and we'll ask them to the speakers. So have a think about any questions you might have about the careers, how the speakers ended up in those careers, or how they did in school, or the specific science knowledge or skills that they need to do those jobs. And we'd be really, really happy to address any of those questions towards the end of the session. So we're going to go around in the same order through the speakers and ask them to give us a little bit more now in-depth presentation about how they started off, how they got to where they are today, and everything in between. So we'll go to Marta first, please.
Thank you. So my background was slightly different. My mother was one of the physical traders in metals, which was quite rare for a female when we're talking about 40 years ago and plus. And my childhood was probably slightly different to most of the girls. I was spending a lot of time on the recycling plants, production lines, mines, so basically being surrounded by metals, physical material that you take out of the ground, and seeing that material from a very young age being recycled into something that you then pick up. Think about your phone, and of course we didn't have mobile phones back then, Coca-Cola cans, this is without sort of promoting a brand, or anything around your house that consists metals, plastics, etc., etc. I then, since both of my parents were in the business, it was deemed to be a dirty business to be in metal. So sorry, I've got pop-ups every now and then because I'm logged into my own system. So my father said, no, you must be a lawyer. That's more for female, that's more for girls. Or my mother was a trader. So I've ended up starting when I was 18 on a work experience, and not realizing just how much I knew by purely being and seeing the physical metal and that transformation. Turned out that not many traders even see that the physical aspect. They see the numbers, they see a futures market, they see all those things that you read in the papers. Cutting long story short, after work experience, I got offered a job and I started working as a sort of junior assistant and working my way up still done my law degree because I think that is very important. Education was always important in my house. My mother insisted that I still get a degree and then I can decide on my career path. And how did I merge the two? I still qualified as a lawyer, but never went to work as one. I now been in metals industry for 22 years, without giving out my age. And of course, all the background that I've seen, all the things that I've seen growing up, I understand and I'm very passionate about metals, and I genuinely, and the recycling and the whole cycle. So I grew up looking at the physical material, then went to trade think about stock exchange just for metals. It's just different product. And now I advise my clients, the biggest producers, recyclers, funds, so your parents' pension fund, etc., on how to use the materials. And just interesting information, people think of recycling as something new, something that maybe popped out in the last 10, 15 years because it's trendy. It's actually not true. The very first reusable battery was invented in 1859. The problem was that the guy who's done it never, and probably the ladies who are present know more about batteries, he never actually filed for a patent. But it's not a new technology. And metals, I've got a lot more information, very happy to send you details. Metals are actually almost 100% recyclable. Once you take it out physically off the ground, you start producing, you enter that cycle, it is constantly being reused and recycled without losing what it's meant to do. And that's why everyone pretty much relies on it. Still being number one, close followed by aluminium. And when you compare it to, let's say, glass, which is also a household material, that is not recyclable at all. That just ends up on a landmine. And I know the ladies probably who, Yvonne who's doing PhD, there's probably a lot more PhD students looking into recyclable aspects of that, but that's not my my sort of forte. And how we come into it, every single company that trades on the LME or is involved on the London Metal Exchange as a producer, recycle, trader, has to fill in certain criteria in terms of responsibility, sustainability. By responsibility, without going into too many details, we're talking about where the material physically comes from, who's been involved in getting that material out. For example, has there been any underage people, any human trafficking, etc. So that's separate, long topic. And then you're looking at sustainability and keeping it in the cycle, and of course not using too much carbon, etc. So it's a huge topic that I'm sure we can talk for weeks and weeks and weeks, and I've got a lot more to discuss. So that's sort of introduction for me.
Oh, thank you so much, Martha. Okay, well, again, please feel free to pop any questions in the chat for Martha, and I'll come back to those in a little bit. For now, we'll move on to Sarah and find out about her job.
Hello, I hope you can hear me well. I'm going to try to share my screen because I want to show some slides that are going to make my life easier. If you can see it, please give me a signal.
Yeah.
Can you see it?
Yeah,
cool.
Thank
Perfect.
you.
So, well, my name is Sarah Vidal. I'm Spanish. I come from Madrid, but I've been living in London for 5 years now. How I came here? Well, when I was in year 7 or 8, I just have a clear idea that I wanted to study science. But I was stopped in. For a bit, I wanted to be a pharmacist and then an architect to make houses. And then by year 11 or 12, I knew I wanted to do something to help the planet. So I decided, or biology or chemistry, even if there's so many degrees that can help the planet, I chose just between these two because I really liked it. So I decided to do chemistry, and in my second year, degrees in Spain are a little bit longer, 4 years instead of 3 years. I started to do some research about artificial neural networks that are like some tools that are very interesting for many fields. But it basically showed me how fun it was actually to work in a lab and with a research team. It's something that I really miss right now. but yeah, so by the last year, I decided to study all the subjects related to the environment. So, for example, environmental biochemistry, environmental technology, analytic chemistry related to the environment. So all of this. And then when I finished, I wanted to do a master's degree to be a bit more specialized. And the two of them that actually got my attention more to save the planet, let's say, it was environmental planning and energies and fuels for the future. And I went for this one because basically many of the carbon emissions in the world are caused by the energy generation. So we need to do something about it. So in this master's, I studied all forms of renewable energy, like solar, photovoltaic, that is produces electricity, or thermal, that produces heat, wind power, tidal energy with the waves of the sea, everything. But I focused, because I studied chemistry, I focused in lithium ion batteries and how the chemical reactions were inside. And I did a bit of research for new materials for lithium ion batteries. The lithium ion batteries is only one kind of the batteries. There's so many types, but this one is the one that people use the most now. There's the ones that are on our phones and the tablets, and at grid scale, so basically thousands of them together connected to the network. And now I'm developing this kind of projects in the UK. So I'm gonna don't hate me. I'm gonna explain a little bit about the electricity system, so you can follow what I do. So the electricity system basically is based in generation, where we have the renewable energy, the ones that I told before. We have the thermal energy, the one that we've used always, like coal and gas. It's very contaminating. And we have nuclear energy. It's not that contaminating, but it has other problems as well. All of that is connected into the distribution and the transmission systems, and they are sent to our houses through these high voltage cables. So this is basically a summary, quick explanation. There's different voltage in these systems, and the voltage is basically the force of the electricity. So you need more force, more voltage to transmit it long distances, and then shorter lower voltage for short distances. All of this is basically towers, the big pylons that we see all over the country, and the substations. There's basically a place with a lot of electrical equipment that just basically drops the voltage and makes it that you can have it in your house and you don't get killed when you switch on the kettle, basically. So we have the generation and demand in the UK. So basically, well, everywhere, you generate the electricity that you need. So your demand is the electricity that you need in your house to switch on your TV, your washing machine, and everything. And it changes through the day. During the night when we're sleeping, nobody's using it. The demand is very low. During the day, everybody's in schools, on work, and that is a medium demand. But when we finish and we go home and switch on the TV and make dinner and switch on all the lights, that's the demand is higher. So if we use more renewable energy, it can be problems because, for example, the solar energy is only produced during the day. So at dinner time, we don't have solar energy. But wind is only produced when there's wind, and you can't predict that very accurately. So we need energy storage to solve this problem. This is one example that I think is easier to understand. It happens even in small hours of the day. When there's a football match, everybody's watching the TV and the demand is kind of stable. Suddenly there's a halftime or the end and everybody goes to switch on the kettle, open the fridge, whatever, and there's peaks of demand. So for that, you need to deliver energy. Right now, you do it with the energy that you have. You use gas normally. If we don't use gas, we can use the storage that has solar energy or wind energy inside, and we can avoid that pollution. So what do? I'm an energy solution specialist. That doesn't tell you anything at all about my job. I'm actually a project developer, and I also manage all the pipeline. So basically what I do is I connect all these batteries, like your phones, or your tablets, all these batteries, thousands of them in different containers, and you put them unconnected to the network. There's a lot of work before that, so I'm going to give you a bit of hint what I do. So first, I have to find a connection in the network. It can be one of those big towers, or it can be one substation, and it has to have capacity. So the engineers have to tell me that if I connect my batteries there, the network is not going to go down. I need to find the land. I need to find the land that doesn't affect environmentally, has a bad impact around our landscape. It doesn't look awful in a rural area. The owners have to be happy with them, and it has to be kind of close to the point of connection, because long cables are very expensive and produce more electricity losses. And then we have to select the technology, the batteries. We need that they're environmentally sustainable, so the production is as clean as we can, and socially sustainable. We have to make sure that the production is not related to child or forced labor. Then we need to get planning consent. So it means that the council has to be happy for us to build the batteries wherever we build it, outside a town or in an industrial area. It depends. And we have to do a lot of reports for it, like take into account the budgets, the bats, all kind of like everything that you can find in the site. And also sometimes we have to propose to put trees around it, so it doesn't look like that awful. It's not awful, but and the best part for me, my favorite, is to design the site. So I have to do all the drawings and calculate the distances and everything to make sure that the site is safe. I don't do it alone. I have a really big team behind my back, but this is my favorite part, because I've always liked design. So it's really, really good. And also I do a bit of work for the international team, and this is really good fun as well. So the international team in my company, they do microgrids in remote areas like islands or remote areas that don't have the electricity, don't get there, and they have their own diesel engines to produce electricity. What we do is we design solar panels connected to batteries to reduce the fuel usage. Sometimes we combine the three of them, solar, diesel and batteries. Sometimes, because if you only cover with solar batteries, it's very expensive. You need a really big battery to cover the whole night. But I need to model systems. I need to calculate how big we need the batteries to be, how big we need the solar system to be, and how much money we're going to save in fuel usage, because we're not going to buy more fuel, or we're going to reduce it a lot. And basically a little bit of summary of what is the impact of the battery energy storage systems. As I mentioned before, in 2020, the carbon emissions from energy supply in the UK was at 21%, just after transport being at 24%. So this is a lot of emissions comes from the energy supply. There's a difference between the energy sources, fossil fuels and nuclear. We can decide when to burn or use the fuel, and it can be used when we need it. Solar power, it generates during the day and when the sun is shining, but if it's cloudy, it generates less. And the wind power, who knows? It comes and goes. So this is an example. We have the yellow line is solar power. It's an example of solar power, and the blue line will be wind. So the energy storage, when there's solar or wind produced and it's not used, in the batteries we can store it and then release it afterwards when it's needed, instead of using coal or carbon or other dirty technologies. So basically energy storage is essential if we want to stop using fossil fuels and we want a clean environment. And that will be it. Yeah.
Amazing. Thank you so much, Sarah. That was so interesting. I was engrossed. We have a question in the chat, but I'll wait till we've done all the presentations and I'll come back to that. So we've got Yvonne up next.
Fantastic. Let me try and share my screen. Let me know when you can see my slides.
I can see.
Yeah.
You see that?
Yeah.
Fantastic. Well, it appeared for you before it's appeared for me. Oh, there we go. All right. Well, thank you all very much. Thank you very much, Sarah. That was a fantastic presentation, and I think leads quite nicely into what I'm going to talk about. So hopefully that should go well. So a little bit about me first. You might detect a hint of an accent. I did not start my life in the UK. I actually was born in Australia before moving to the US, and then moving to the UK. And I keep hopping back and forth between the two. I can't make up my mind beside the Atlantic I want to live on, apparently. But I did secondary school here, And I knew, like Sarah, that I wanted to do something that helped people. But I thought I wanted to be a doctor. And then I realized that I was terrified of blood, and that was probably not the right path to go down. And so I decided to go into something that related to climate change, which is how I got into batteries. And like Sarah, again, I initially was interested in photovoltaics and renewable energy systems. And I learned when I was doing my undergraduate degree at Northwestern in the US, that actually renewable energy systems are doing pretty well. The technology is pretty good, but the batteries really need a little help to get better, so you can really push and use them on a larger scale. So I've included a couple of pictures that sort of show what my day-to-day looks like. Wearing lots of PPE, lots of protective clothing to make sure I stay safe when using chemicals in the lab. I'm a microscopist mainly, so a lot of my time is actually spent using that bit of equipment you can see behind me in that lower picture to take pictures of really, really small things. And I also wanted to touch on, I do a lot of things outside of just my job as well. So don't feel like whatever you're doing, you have to give up your passions on the side. You passion about your job and do other things. I think that's very important, whether that's, for me, it's sports, or other people might be music or art. Follow all of your dreams. You can do everything all together. So Sarah described this far better than potentially I could in the time I have. So as she said, we need batteries in order to get rid of fossil fuels from the grid. They help balance out the grid so that we can use renewable energy, clean energy, and to power our homes. And then the other thing I wanted to bring up is powering transportation. So not only if we have better batteries, not only will we be able to power our homes without using environmentally damaging sources, but also cars, trains, planes, potentially, although that's a little bit further down the road. So that's something that could be really exciting. If any of you live in cities, you might be familiar with just how hard it can feel to breathe sometimes when there's so many cars on the roads, and hopefully we'll get to a point where that's no longer the case. So what's the problem with batteries right now? Why can't we just immediately jump in and stick batteries everywhere and it'll be perfect? So Sarah touched on this as well, is mining is a big problem. So a lot of the components that you put in batteries come from countries that don't have very good regulations on their mining practices. So they can be very environmentally damaging and very socially damaging because the people who work in the mines don't have protections in place that we would have here. So that's something that scientists have to take into consideration when you're trying to create new batteries. Money, unfortunately, makes the world go round, so you do have to consider how much the materials you put into your batteries cost. If we're using really expensive components, then it's not going to be able to be used in everyone's car. And then the toxicity of batteries. So lithium ion batteries that are currently used, it's actually very hard to recycle them because of the toxic nature of a lot of the components in them, because they have to stay very tightly sealed so we can stay safe. And so it's difficult to reuse those components. And finally, and potentially most importantly, performance. So obviously we want our batteries to last as long as possible. And that means both in terms of how long one charge lasts. So wouldn't it be wonderful if our phones could stay charged for a week? Wouldn't that be amazing? You wouldn't have to worry about charging your phone every night. But also, if you never had to replace your battery. I don't know if you ever heard your parents or yourselves complain about having to replace their car battery. Imagine if it just continue and go on forever. It never wore out. Wouldn't that be? It would be wonderful, right? And another big thing is the weight. So I'm not sure if you consider if your car had a battery in it, it was really heavy, it's going to not go very far. But if you make that battery a little lighter, even if it stores the same amount of energy, you can go a lot farther. Think about, it would just be like carrying an extra suitcase around with you everywhere. So how are we solving these problems? So current batteries, so lithium ion batteries, we talk about chemical mining. So in the new batteries, we're looking at using safer sources and different chemicals. So for example, lithium ion batteries, there's now mines opening in the UK, which are safer and have much better regulation. Or we can also use totally different chemicals. And this is more where my research comes in, because we're looking into totally different chemistries that can be used in the next 5 to 10 years. Next, expensiveness is a similar problem. We can use cheaper materials. And so again, this is where my research comes in. We're looking into new materials that we can use that will be even cheaper than the current batteries. And toxic materials. So this is, again, we want to be able to recycle, kind of going back to what Marta was saying about metals. A lot of the materials in a battery are metals, but if we can make the other components less toxic, then it's much easier to recycle them and make the whole system much more sustainable. You can use different components, or just reduce the amount of toxic components. It makes a huge difference. And finally, right now, there's one battery type, lithium ion, one chemistry that is used for most applications. But there's a lot of different ways that batteries are used. It doesn't seem to make sense to use the same kind of battery in your phone as in your car. So scientists right now are looking at lots of different next generation batteries that can be specialized for different applications. So this brings on to what I'm working on. So I'm working on lithium sulfur batteries. So typically these type of batteries are good for airplanes or drones, things like that, because they're very, very lightweight compared to the current batteries. So that's why I've got a little drawing of an airplane there. So what's different? So right now in lithium ion batteries, you've got graphite and lithium. In the batteries I'm working on, we're replacing that with just pure lithium. So that reduces a little bit of cost and some weight, because you don't have that extra component in there. Also replacing potentially toxic liquid electrolyte. So that's the part of the battery where if you've ever seen a battery go bad, you might have seen gross corrosion come out of it. That's usually the liquid electrolyte. And if you replace that with a solid, it's much safer because it's much less likely to sort of flow out of the battery, and it'll stay where it's meant to be. And finally, I'm talking a lot about these toxic metals, toxic components. Instead of using those toxic metals, you can use sulfur and graphite on the other side. And sulfur is found pretty much everywhere. It's one of the most abundant elements in the Earth's crust. So it's much easier to get access to in safe ways for the environment and people. So those are some of the benefits of this next generation chemistry that I'm working on. However, they don't quite work yet. So that's where what I'm doing comes in. So I said I was a microscopist. I take pictures of very small things. So each of these pictures I'm showing you here, if you think about the size of one hair, that would be bigger than what I'm showing you in each of these pictures. What I'm trying to do is trying to figure out why these batteries aren't performing as well as the current state of the art and how we can get them to that point. So I'll give you a little sneak peek in what these photos are showing us. So for the lithium, as beautiful as this picture is, we want it to be nice and flat so that we know exactly where all the lithium is and it can go back and forth to where it should belong. Right now, we have this problem where lithium likes to form these beautiful patterns that aren't very useful for battery chemistry, because this is what can cause batteries to fail and not last for very long. For the solid electrolyte in the middle, those big gaps you can see, that makes it harder for the battery to charge and discharge, because it's more difficult for the lithium to move across. So we want to try and make it as dense as we possibly can. And finally, you can probably see the problem with the last photo. Big cracks usually are a bad sign for most things. And yeah, so often with sulfur, it can be quite brittle. So after you charge and discharge your battery, a lot of times you get cracks, and that can reduce the performance of your battery. So that's a little sneak peek into what I'm working on and what I use my microscope to look at. And I wanted to just briefly talk about what you can do as well. So it's I think batteries are fascinating personally. Maybe I'm just a nerd who likes looking at batteries. But if you wanted to get more involved or learn more about this, you can always read more about it. You can talk to your friends about it. And if you wanted to get involved later in life, there's so many different ways to get involved in battery related like energy related careers. It doesn't have to just be as a scientist or working on a field. There's art. We need more artists. We need more programmers. We need more teachers. All of that, whatever you're passionate about, it can be related to these kinds of things if you take that into consideration as well. So yeah, I just wanted to touch on that. Thank you very much for listening.
Amazing. Thank you so much. Again, so interesting, and thank you for making it super clear for all the students on there as well, because some of that is quite complex if you're not careful to explain it clearly, but you did. That was great. Okay, great. So we've got our final speaker is Laura.
Yeah. Lovely. Thanks very much. So if we can start with the next slide, please. So hi everyone, I'm Laura Tunnicliffe. Just a little bit about myself first. So my hobby is walking. I love being outdoors. I love dogs. I love photographing wildlife. So for me, nature and sustainability is a real big passion. Yeah, I work for Hitachi Energy, a massive electrical engineering company. So why? How does that fit in with sustainability? I have the next slide, please. So electricity is integral to sort of making sure that we achieve a reduction in our carbon footprint. Virtually everything we use is electrical now. We've got like a growing population, we've got more devices becoming smart, we've got more transport that needs electricity to run. So we have this ever-growing demand. So the challenge that we're faced with is how do we meet that demand in a sustainable way? So one way is to use more renewable energy, such as solar or wind, but a turbine on its own, it's no good. It needs to be connected to something. So this is where the national grid comes in. It transports electricity, through a network via a substation to your homes. Another way we can sort of meet this demand is by making use of the infrastructure that we've already got. So a lot of equipment that distributes electricity up and down the country was actually built in the 1960s. It's crazy. Like technology has advanced so much since then. I mean, we have the internet now for one. So with the use of the internet, we can sort of utilize data to make sure that power is sort of being directed in the right place at the right time. So it's more efficient. Have the next slide, please. So this is what Hitachi Energy kind of do. So we help sort of connect these power generation sources, like your turbines, to like substation equipment that's designed to sort of efficiently control and direct electricity to things like your electric bus depots, electrified train lines, shipping ports, data centers, battery energy storage systems, and that kind of thing. So if you have the next slide, please. How do I fit into this picture? Well, I'm a health, safety and environmental advisor, which means it's my job to make sure that we're keeping people and the environment on our construction sites safe. So I studied physical geography at university, not a traditional science background, but I did a research in maths of science, which sort of gave me an appreciation of like the application of a scientific method and how to sample data, how to statistically test the significance of data trends, and that kind of thing. And then once I graduated, I got a job in supply chain. So I worked there for a few years, but I found that I wanted to get out of the office a bit more, and I wanted to have more of a sort of direct influence on reducing environmental impact. So I enrolled in an apprenticeship program, I retrained, and then I sort of used this to get a good sort of grounded in engineering principles and sort of help develop my math skills a bit further, while sort of learning on the job, like the responsibilities of a Hse Advisor. So what do these duties kind of entail? Well, before we start construction on a site, we commission a bunch of specialists to survey the whole area. So one of my key duties is sort of taking these scientific reports, interpreting the technical information, and then communicating that back to the rest of the project team in a meaningful way. So this helps us sort of determine what our environmental impact would be and helps us to sort of look at ways that we can reduce it and mitigate any environmental damage. So for example, an ecological survey might say that there's bats roosting nearby. So we can then sort of erect a noise enclosure that will help muffle the sound and sort of minimize the disturbance to the bats. So another part of my my role is to sort of collect data and do some analysis. So I gather information on a whole host of things. Those things like what materials we're using on site, how many miles we're driving, how much fuel we're using, how much waste we're generating. So you can't really make a direct comparison between like litres of fuel and tons of waste. So you need to find a common denominator. And what I do is I, convert all these values into an equivalent of how many tons of carbon that would be like releasing into the atmosphere. So this helps me sort of identify trends and show hotspots that can be targeted to make sure that any improvement measures we implement are sort of focusing on the right place. So if we have a next slide, please. So I've got some examples here of some like sustainable initiatives that we've sort of implemented that have come out of this data analysis. So one is a lot of our carbon emissions come from travelling to and from site. So we're looking at transitioning our vehicles to be electric. We're looking at having more of these tool hiring stations on site. So you've got all your tools that you need for the job in one box on site, one delivery. You haven't got to go to Screwfix all the time. So we're reducing carbon from travelling that way. We also know that diesel is contributing to really poor air quality. So on some sites, we've used things like battery-powered lighting columns and hybrid generators to reduce the amount of diesel that we're being used, which is better for human health because you haven't got as many sort of harmful diesel dust particles in the atmosphere, as well as better for ecology because it's using less carbon and also the quietest. So they're really good for like noise-sensitive areas. And another example I've got is, how we've worked with our factories to sort of look at how much waste we're generating from the packaging that's around our products. So the site, the photo in the bottom middle here, we've got this. This is a massive piece of kit here that would have traditionally just all been a solid wooden crate, weighs tons. So what we've done is we sort of reduced it to just a framework that will protect the equipment in delivery, but it's less raw material that's being used. It's lighter for traveling, so it's less CO2. Another example is where on a small kit, we've used a metal frame that's incorporated as part of the design. It's got these little 4 holes you can see. So it's got these series of holes that are attached to the frame. So you can connect that to some slings, lift the equipment. You haven't got a need for this crate to transport it. So if we have the next slide, please. So these are just some examples of the kind of things that I've been involved with on the project sites. But that's just a really small picture of a much bigger puzzle. So one of the advantages of working for like an engineering company is that there's so many different roles that are needed to actually implement a project. So you have your electrical engineers that do all the wiring and testing, to mechanical engineers that specialize in lifting and the mechanics of the build, to people who work in supply chain that sort of focus on sourcing cleaner and greener sort of components to make the stuff out of, to people who work in sort of R&D and are looking at the technologies of the future that will help drive efficiencies. So that was just a bit of a whirlwind overview there of how sort of like the core principles of both like maths and science that you're learning in class today can actually be used to sort of drive these sustainable improvements, whether that's on a local level, on like a little project site, to the much bigger picture of where we're building equipment and infrastructure that actually will help the country achieve its sort of net zero ambitions. So
fantastic. Thank you so much, Laura. Again, super interesting. It's interesting how different things are linking into the electricity topic, but from different angles. That was great. Thank you. So we've actually just got about 5 minutes left. So I'm going to ask some of the questions that have been popped in the chat here, and we'll go around again in the same order and get each of your takes on this. So the first question was, do you work with many women in your current role, and what advice would you give to girls to get ahead in this industry? So let's start with Marta. Oh, 1 sec, I think you're muted, Marta. Are you able to unmute? Oh, here we go.
Can you hear me now?
Yes, I got you.
Yes, apologies. It's a system. I have no control. It goes in and out. Sorry, to answer your question, the answer is no. As I've mentioned at the beginning, my mother was one of the very first females, and the industry, metals, was considered to be dirty industry that female just didn't go into. As I said, my childhood was spent going to production lines, recycling. I've seen more batteries and actual piles of metal scrap. Because when you think about it, when you take the any component, once the life of it comes to the end, you just chuck it away. But then another company will collect it, take it, separate it, recycle it. It's dirty, dirty, dirty. So no, naturally, it's not a business where female go. I obviously went because of my mother. I remember talking to my colleagues at the time, my school friends, saying, "Oh, I'm going to go into metals," and their idea of metals was me standing with a pile of metals somewhere in the market Saturday morning selling it. There was literally commodities and that wasn't a topic popular. So naturally there weren't that many women. When I became a trader, I was the first trader in my company in probably 30 years. And I can count on one hand the amount of female traders in the industry up to now, and we're in 2022. Reasons are different. It's a very competitive industry to get into. Men are more sort of powerful, and I always say no. I remember when I was sort of 21, so obviously a little bit older, and I said, well, hold on a second, there hasn't been a female trader for a while. Can I study to be one? Can I understudy a male colleague? And they literally looked at each other and went, I suppose so, because no one's asked that question. We do employ female colleagues, but they quite naturally go into the role of support, accounts, sort of client support, but we don't tend to see that many traders. And that's something that I would love to see change, because females are as good, if not better. We can multitask. And I'm speaking from experience, we probably cope with stress a little bit more, because multitasking for us is not a big woo-ha, whilst for boys it's like, oh my god, I'm concentrating on one thing and one thing only. And why not? I see absolutely no reason. The one thing I remember someone told me was act as a lady. And that was the best advice that anyone's given me. There's no need, we have to become one of the boys. We equally intelligent, we all got degrees, you've got school degrees. Get as much knowledge as you can, because boys always stick in a boys club, but there should be a girls club, so to say. I've now, as I said, been in the business for 22 years. I'm one of the senior advisors, so I go to all the places that you've shown on your slides and advise my clients how to sort of hedge their risk. And I've never met anyone with less than respect for me as a female. So definitely, and it's the industry of the future. Let's face it. The recyclability says that's all going to only get you've mentioned lithium batteries, EV batteries, or electric vehicles batteries. Everything is going that way, and there'll be more. And sorry, just the last point. There's even products touching. You think metals, future technology. Where is that all linking? One of the projects that my company is working on currently, and the contract just been signed, and that's came out of COVID, so it's very recent. One of our physical companies producing tin powders is cooperating with one of the biotech companies, and every time you go shopping, let's say Waitrose or Marks and Spencer, you tap the till on the checkout, the bacteria stays on that screen. Yes, you might use a hand gel, but probably 20 people before you have it. The new technology coming in, we're using metals to produce this shield screen, and the biotech companies coming in using coming from their side, I can't speak for biotech, and the bacteria will be killed within less than 1 minute. So that's the sort of another future angle. So yeah, no, definitely need more girls. Sorry.
That was great. Thank you, Magda. Sarah.
Yeah, no, there's not many girls in this industry. In my office, well, we're a really small company. We're like 12 people. There's only one other woman that works in my role. Then we have an office manager and a director, legal director. We're 4 women in this company, 2 of them working in the technical side. But when you go out in the events with distribution and everything, see women in engineering roles, we're less than 20%. So I think it's super important to have more women in this industry, and it's not because they're not they're not there. So my boss tries really hard to hire women in the technical side and only receives male CVs. So it is really important to be here.
Yvonne?
Yeah, unfortunately, I've got to echo the other two and say it is about 20% in my office about women. I would say I've been lucky in that most of the men I've worked with have been very nice about it, and I haven't come up against, as Mark said, many people who are rude to me because I'm a woman. But I have sometimes felt a bit lonely. So if I was to give sort of one piece of advice, kind of relating to what I said at the beginning of the presentation, is have other hobbies you do outside. Find your group outside of work, or else where maybe you have more girlfriends, if that's what you like, who can sort of balance that out a little bit. That's helped me going through.
Thank you. Laura?
I'm afraid I have to sort of echo what the other ladies have said. So, you know, I'll go to a construction site and I'll be the only woman there most of the time. I think there's a few more women who are in sort of the functional support roles, so like health, safety, and environment. What we've been trying to do to sort of encourage and support the women that we have got in the industry is we've got these sort of female networks that we've been building. So to sort of support other women in different roles and reach out and just connect, so you don't feel isolated, you're not the only one, and sort of focus on developing skills. So I'm not being, you know, no disrespect to the gentleman, but if there's a job advert, you know, it's got a list of points. You need to do X, Y, Z. Oh, you need 10 years experience. Generally speaking, if a man's applying for the role, oh, I've only got 8 years experience. No, I'll apply anyway. I'll give it a go. If a woman sees that I haven't got exactly 10 years experience, I can't apply for the role. So we're trying to sort of help, you know, develop our female colleagues to sort of get past that and help support each other. So I think my best advice for any women who want to sort of go into engineering is just go for it. You can do it. Anything you can learn, you know, you can learn on the job. So I think that's where like an apprenticeship scheme is actually really beneficial, because it doesn't matter if you haven't got the knowledge, you can develop that. You can, you know, skills are just as important as actually knowing, you know, facts, I'd say.
Absolutely. And one of the things which has come out on these calls in the past is many of the people who are working in STEM careers actually didn't feel like they were really, really good at science in school. And people have this misconception that you have to be amazing at science in school to do a science career. But actually, there are so many science careers out there. There's, you know, there will be something for every interest and for every level of ability in science. And, you know, you don't have to be amazing at maths, so you don't have to be amazing at science to be really fantastic in a science career. But yeah, we very much hope those stats about women in these kinds of careers is changing and will change in the future. And I think things like this, where students are seeing women being successful in STEM careers, is such a huge part of that, because it hopefully will show students on this call that they too could be successful in those careers, and hopefully they've identified with some of your backgrounds or some of the careers and things that you guys have worked on. So thank you so much for sharing, you know, about your lives and your careers and your pathways. It was super interesting. I really hope that the students on this call found it interesting as well. Unfortunately, we don't have time to get into any more questions, but if anybody wants to send in any questions, we'll be sure to share those with the speakers and send around that information afterwards. So have a lovely evening, everybody. Thank you so much again, and hopefully we'll see you soon.